Alright. Similar polygons. Similar polygons are figures that have the exact same shape, but a different size. Two very important properties for looking at similar figures. Right? I guess I should first mention the notation. Okay, this is our notation to denote similarity. Okay, it's just a squiggly line. Okay, so this would say triangle ABC is similar to triangle XYZ. Okay? So what similar or similarity means is that first, all pairs of corresponding angles are congruent. Okay, the angles stay exactly the same. So just like we did for congruent statements, right? We looked at saying triangle ABC was congruent to triangle XYZ, and we used that statement to match up corresponding congruent pieces. We're going to do something similar with our similarity statement. We can say, just from this statement, that angle A is congruent to angle X. Right? We can say angle A is congruent to angle X. Two figures are similar. The angle sizes stay exactly the same. Then we can say angle B is congruent to angle Y, and angle C is congruent to angle Z. So the angles stay the same, but the size of the sides changes. It changes in a specific way, though. The sides will still be proportional, right? So that's the reason that we did dilations first in this chapter, is because essentially what we're doing, if we're looking at similar figures, we're kind of looking at a dilation. Right? We're saying, well, to go from this one to this one, I'm going to multiply each of the sides by a scale factor. It's going to change proportionally. So I can write the sides as proportions, the corresponding sides as proportions. So I can say that if I look at my statement, AB matches up with XY, that means they're going to be proportional to the other sets of sides. So what I can say is AB over XY. Okay, matching up corresponding sides and writing it as a fraction. So I can say that fraction is equal to, and I can match up another pair of corresponding sides. So BC, YZ. And then my final pair of corresponding sides would be AC and XZ. So if two figures are similar, the corresponding angles are congruent, and the sides are proportional. Okay. So in this second example, we're given two figures with some side measurements, and we're asked to determine whether the figures are similar or not. For two figures to be similar, we have to have all pairs of corresponding angles congruent. So that's the first thing we want to look at. We want to see if I can match up all four pairs in this case. Well, I can say W is congruent to P. I can say Z is congruent to S. I can say Y is congruent to R. And I can say X is congruent to Q. So I can match up all four pairs of corresponding angles. The second thing we want to do is look at the actual numerical values of the proportions. So if we compare corresponding sides, WX and PQ match up. So if I write the actual fraction of the sides, 12 over 8, and then reduce that as far as possible. So 12 over 8 would reduce to 3/2. So I can say that's the scale factor, right, of WX to PQ. And I want to do the same thing for the other three pairs of corresponding sides. So if I do XY over QR, 18 over 12, and that would reduce to 3/2 as well. YZ over RS, 15 over 10, which again would reduce to 3/2. And then finally, ZW over SP, 9 over 6, which would reduce to 3/2. So if this happens, if all pairs of corresponding sides have the same scale factor, that means they are all proportional, then the figures are similar. So we wrote a similarity statement here. WXYZ is similar to PQRS. And then we could say the scale factor, depending on which direction we're going. Okay, we could say the scale factor of WXYZ to PQRS is 3 over 2. Or if we go the other way, we could say the scale factor of PQRS to WXYZ is 2/3. Okay. Questions so far? All right, let's take a minute, okay, and see what we can do with a couple of these. We don't need to do all of these. How about we just try 1 and 4. What's up? Let's try 1 and 4 here. Because we're told, really, for one, we're told they're proportional, or they're similar. So we know that the angles are congruent and the sides are proportional. Just want you to list them out.
You were supposed to do one half.
You didn't feel like writing equal. You just wrote after angle after. What'd you put for 4? Because it was 0. Huh?
If you had a coronavirus, you're going to alcohol in like really hot place.
What should I tell you? She busted Cameron for doing that. It's like a really famous story.
Alright, for the first one here, we really shouldn't be looking at the picture at all, right? We should just be using the statement to match up congruent angles and the proportional sides. So just from the statement, I see that D and G are in the same spot, therefore angles D and G are congruent. Then angle E is congruent to angle H, and angle F is congruent to angle J. Then as far as writing my proportional sides, again, just using the statement, say DE over GH. We can say, wait a minute, I messed up somewhere here. This should be DE, not DF, and then EF over HJ, FD over JG. You okay with that one? Alright, then for number 4, okay, we were looking at triangle PQR and triangle PST. So first, we needed to look at our angles. And we could say angle P is congruent to angle P. And then we have angle PQR is congruent to angle PST. And angle PRQ is congruent to angle PTS. So we have 3 pairs of congruent angles. Then as far as the sides, well, I can easily say QR over ST is 1/2. But then I'm not given numerical values for anything else. But I am told that some pieces are congruent. I'm told PQ is congruent to QS here. So what I could do, if I'm comparing PQ and PS, I could say that PS, since I know these 2 sides are congruent, PS is just twice the length of PQ. So I could say this is really PQ over 2PQ. And then just using algebraic rules, I can cancel out the PQs. This would just be 1/2. I can do the same thing on the other side. Right? Again, since I'm told these 2 halves of the segment are the same, I'm comparing PR and PT. I could say this is really PR over 2PR. Because these halves are congruent, PRs would cancel, and I get that scale factor of that proportion is also 1/2. Questions? Alright. Let's flip over to the back. So, on the back here, we are going to set up and solve some equations to find missing side lengths. Okay? So, in this first example, I'm told that these two triangles are similar. So I can set up proportions to find my missing pieces. Right? Now, these are organized or arranged nicely, so it's really easy to see which sides correspond. Right? I can see that these two, less the 32 and the 16, less correspond. Right? When I'm writing a proportion, I need to make sure that at least one of the fractions just has numbers in it. I only want to have one variable in my entire equation. So what I'm going to do, if I want to solve for x first, okay, I'm going to use this 32 over 16. I'm going to write that proportion. Okay, side rs over mn. And then I'm going to write another proportion to solve that involves x. So the other one would be x over 13. These would be corresponding sides. Okay, so I'm writing two fractions equal to each other. To solve a proportion. Remember how to solve a proportion? Cross multiply and divide. Okay? So if I cross multiply, 16 times x would be 16x. It's 32 times 13. Or 16.
That is 65.
Let's find out this number.
Alright, so then we just divide by 16, and we will get x equals 26. Okay, now that's the foolproof way to do it. Okay, and we'll have to do that sometimes when our numbers are ugly. But if I look at the two values of a pair of corresponding sides that I know, in this case, 32 is exactly twice of 16. Right? What that means is these three side lengths are going to be exactly twice their corresponding sides. Right? So we just found that x was 26. That's exactly twice 13. Okay? So if you can recognize something like that, you don't have to go through this process here. Okay? We can then say, well, I know y is going to be exactly half of 38. Well, it's going to be 19. Okay? Now we could set up our proportion. We could just use the same 32 over 16, say that equals 38 over y. I guess one thing I should mention, it is, when we're setting these up, it is important. So if I put big triangle over little triangle in my first fraction, I have to stay consistent and put big triangle over little triangle in my second fraction. I'm setting these up. Okay. So cross multiply 32y 608. Thank you. Divide by 32. Get 19. Kind of. I mean, on the back here, we're using the proportion to solve for missing sides. But on this example, it does ask for the scale factor and then the perimeter. Right? So we're doing something very similar over here. Right? So we're told that these two figures are similar. And we can say, well, I just want to match up a pair of corresponding sides. So EF over HJ. it would be 8 over 12. And I can reduce that fraction. Say that's just 2 over 3. So what I could do then is just take each of these other sides and multiply by that scale factor. Or I guess set equal to that scale factor, I should say, not multiply. So if we call those sides x and y, I just assign some variable to them. Instead of using 8 over 12, I can use the reduced form of that. I can use 2/3. So I could say 2 over 3 is equal to 10 over x. And then I can also say 2 over 3 is equal to 12 over y. Again, cross multiply. 5. So we get this side is 15. Same thing here. So y equals 36. Divide by 2. Y is 18. And now we could have actually done that same thing over here. To make the arithmetic a little bit easier, we could have reduced this 32 over 16. We could have just said this is 2 over 1 equals x over 13. Right? So if you can recognize that you can reduce a fraction, that may make the arithmetic, the solving, a little bit easier. All right. Questions? Because it's not always going to be easy. Right? We want to show you the process for problems that you're not just going to be able to say, okay, the scale factor is 3 to 1, so I just multiply by 3. It's not always going to be that easy. Sometimes the scale factor will be 14 to 11, and you're not going to be able to do that in your head. And sometimes also we'll have variables, like in the example down here, like the fourth example. No, actually that one's not the one. Oh, I guess I didn't put one of those on here. There are other ones that involve multiple variables that we can't just multiply by a scale factor. We'll have to set up a proportion to solve. Any other questions? All right, let's take a few minutes then and see if we can solve for x on a few of these.
Tell us that if you want to do it,
mean, is this 10? Or is it 1? Where's this?
That doesn't even matter. You're just trying to find that.
Let's see, 9. This,
This side is
13,
50.
15, I'm doing math.
Okay.
12 to 8. It's 12 out of 8. It's 3.
Oh,
Oh, it's 3, 2. 3, 2, 12, 9, 6, 8. Yeah, but that would be too easy, wouldn't it? This one, I'll speed on this one too. That's why I did it is 2.25. I'm smart. This one, but speed on. Why is that reaching like three halves?
It's the easiest, hardest one that can come up.
What's 3 halves? What's 2/3 of 24?
What's what?
2/3 of 24.
16.
16, so X would be 15.
Okay, but like, how are they gonna do that with Tony? No,
Oh yeah, they do.
yeah.
Pretty much every school.
I used to live here and I used to live why don't they just send me?
You'd rather go to court?
Yeah, I never had. I didn't think they just make me sign an icon and I had get ready to drop here. I had like 4 or 5.
There's no numbers. Number 5.
So, what are you gonna do better this time? I
What do you mean
promise
there's no numbers?
to get the card.
Oh my god.
I promise.
Never
I
mind.
promise.
So I thought that was a normal question.
Yeah. This is.
Yeah, I didn't see that.
Oh, right. Yeah.
All right. I remember
Do we have to actually how many fractions?
for the scale factor, or did you have it as 0.8? How you went the other way?
Yeah.
So, yeah, I guess.
I don't like fractions. Fractions are
It's
actually
just by. Yeah, okay.
calculator. I do different, you know. I don't know.
Okay.
It's been there for a long time, so
It is, yeah.
It's pretty fun.
No, I just didn't do all.
I don't know. I've been having to do this for a long time.
I did the scale factor. I just did it.
What do you want to call it? These have been my air tests and stuff for the past 4 or 5 years.
6.
On everything.
Alright, let me talk about a couple of these real quick here. On number 3, when we set up our proportion, I can say 12 over 18 is pair of sides that I know both of them equals x plus 1 over 24. So when I cross multiply here, I need to make sure that I'm multiplying the 18 by the x and the 1. So what I'm really doing is 18 times x plus 1 equals 12 times 24. So I could distribute the 18, or I could actually just divide both sides by 18 at this stage. Okay, either way you want to do it. I'm assuming your natural instinct would be to multiply the 18 through, but this way will actually save you a step, I think. So the 18s over here would cancel. You get x plus 1 equals 16. Subtract the 1, and we get x equals 15. Right? Then on number 4, right, it's a lot easier, I think, if we draw the two triangles separately to show that the larger triangle, the entire length of the bottom is 9 plus 6, 15, and then this side's x. And the smaller triangle is 3 and 9, so that we can then set up a simple proportion. Now, real quick, the last one here, okay, it says find the scale factor of ABC to PQRS. So that tells you which way to write the statement. Okay, it's saying put ABCD over PQRS. So 4 over 5